Hi, in this video I'm going to talk about topological coloring and data-defined symbology. So this is an exercise that is going to try to mimic a historic map look where you have different political subdivisions colored so that no two neighboring subdivisions have the same color while using the minimum number of colors required. And it's kind of an attempt to mimic this historic base map, like this US state base map, where each one has kind of a more saturated version of the color as the outline, but as kind of a shape burst fill around the edge. And so we're going to try to mimic this in QGIS. And to do this, we're going to use this topological coloring algorithm. And then we're going to use some data-defined symbology, which is how we're going to arrive at this kind of pencilish, antique-looking border around all these different municipalities. So this will tie in and teach you how to use a couple really powerful features in QGIS while kind of executing a fun cartography example. So we're going to start by using the topological coloring algorithm. So I'm going to open up the processing toolbox. And you'll see that there's a cartography tool set in QGIS. There's an ever-growing number of tools in here, and we're going to use the one called topological coloring. And again, this algorithm assigns a color index to a polygon layer in such a way that no two adjacent polygons share the same color, while minimizing the number of colors required to do that. So municipalities will be the input. We're going to take all the defaults here, and I'll save the output into a GeoPackage. And I'm just going to call this municipalities colored. I'll click OK and run the algorithm. Click close. So I'll turn off the original municipalities layer, and let's look at the attribute table for this. If I open the attribute table, it has all the same attributes that the original layer had, and if I scan to the right, I'll see this new column called color ID that the tool produced. And if I sort these, I can see that it required 6 colors to produce this effect. And now we can use this color ID column with the categorical render to apply a unique color to each municipality so that no two neighboring municipalities have the same color. So I'll go back to the layer styling panel, and municipalities colored is my target layer, and I will switch this to the categorized renderer. The value will be the new color ID column. I'm going to use random colors, and I'll click classify. I don't need this all other values class, so I'm going to select that and remove it. All my municipalities have a color ID, so that's not an issue. And one thing with this random colors legend, you can click the drop down and shuffle those random colors. So if you don't like the set of colors that it first produced for you, you can try again to get another set, and hopefully there's something after a few tries that you like. So I'll go ahead and work with this. The next thing I'm going to do is duplicate this layer, make a copy of it. It'll be called municipalities colored copy. I'm going to turn off this original one and turn on this colored copy, and make sure colored copy is my target layer. And I want to assign a shape burst fill, but keep all of the original colors. And to do that, instead of going into each class, I'm going to use this master symbol button here, which allows me to assign or change values across all the symbol classes simultaneously. So I'm going to select the simple fill component, and I'm going to change that symbol layer type to a shape burst fill. And that's a pretty nice effect, but I'm going to work with the shading style to improve it a little bit. I'm going to use the set distance option and reduce that down to a value of 3. And I want to increase the blur strength a little bit so that the transition between the colors is a little smoother, up to a value of 5. And so now we have a shape burst rendering of all of those boundaries. and still using the same colors as the original municipalities colored. Now I'm going to make another copy of this. I'm going to make this copy the very topmost layer. And it's called colored copy. This will be the last copy we make. And I will go over here to my layer styling panel, make sure I have the right target layer. And I'm going to change this from a categorized renderer to a single symbol renderer. Let me turn on the layer so we can see what that did. So now, again, all these polygons have the same color now. And I'm going to select the shape burst fill symbol layer type, and I'm going to change this for this layer. I'm going to use an outline marker line. So this is a symbol that produces a marker along the polygon boundary, and the default is a red circle. It could be any of the marker shapes. It could be a square or a triangle. It can be different colors, different sizes, and all of that. But the default is this red marker. And so we can see that with the marker line, we have some different arguments that we can use to change the way those are positioned. And first off, this width interval controls the density, how often those markers are produced along the boundary. And we're going to reduce this width interval to something very small, 0.1. So it's going to make the points very dense. And at the size they are, you're almost going to look like you have a solid black boundary in some places between Comuna. So now I'm going to find the simple marker section here. And I'm going to reduce the size of these markers first off. I'm going to make them 0.15. Very small markers, and I'm going to change the color to dark gray. And the dark gray I'm going to use is 90, 90, 90. So I already had that as a common color because I'd gone through this exercise once, but I can put in that RGB value by clicking on this fill color color bar and just putting 90, 90, 90 in. And so just to give you a review of color theory behind the RGB colors, if we have a value of 0, 0, 0, that would represent black, such as this patch right here. If we have a value of 255, 255, 255, that's going to be white. And if it's all the same value, like 90, 90, 90, it's going to be some shade of gray. So again, we'll put in 90, 90, 90 here. And it ends up being kind of a dark gray. And I'm going to use the same color for the stroke. I'll just use pick color to pick that. So the stroke and the fill color are this dark gray. And then down here we have this offset section. So this offset controls how far those points are offset from the polygon boundary. And I'm going to zoom in a little tighter so that when we work with this effect, we can see it a little bit better. Right now we just have these points so densely scattered they look like the solid lines, but we're going to input a data-defined override. So you'll see these little markers off to the side of each one of these arguments. These are data-defined overrides, and these are one of the hidden powers in QGIS. These allow you to use values in an attribute column or an expression to override the input to a symbology input. These are also found in many processing tools. And so with this, for example, here's the size of our points. We could use data from a field, if we had that, to define how big those points should be, or we could click Edit and use an expression for that. So we're going to use an expression for this offset. So I'm going to click the data-defined override for the offset argument and choose Edit. And I'm going to paste in my expression from the assignment. So this offset requires two numbers, the X and Y. So it's two numbers separated by a comma. And so here the first number is a 0. And we're using the concatenation operator to combine this 0 with this other mathematically generated number, which is a random floating point number between 0 and 1 to the third power multiplied times 3. And we can see in the output preview that the first number is 0 and the second number is a small number between 0 and 1. So we're using this to control how far these values are spread off the y-axis of the polygon boundary. So I'll click OK, and you'll see the effect take place. So now we have this effect where within 3 millimeters of the line, these are being pulled off the boundary in kind of a random way. It's a random floating point offset. And it creates this almost pencil-ish, hand-drawn appearance that we had on historic maps. And you'll see now that we've put this data-defined override there, we get this data-defined override turned yellow, meaning it has an active override, and the little sigma indicates there's an expression controlling it. And if we hover over it, we see the preview of the expression in the little yellow pop-up that we're using. And just to talk a little more about this expression, what really is driving it is this 3. If we increase this to a bigger number like 5, then we'll get those offset points farther from the polygon boundary. So in this case, with a little experimenting, I found that 3 pretty much matched the distance of the shape burst fill. So it works quite well. So now we're just down to the final touches. We're going to turn on this municipalities colored layer, which is solid, and we're going to expand the layer rendering section of it, and we're going to give it a multiply blending mode. And we're going to make it almost transparent. We're going to slide the opacity slider down to about 25%. And then lastly, for this municipalities colored shape burst fill, we're also going to use a multiply blending mode for that and knock the opacity down to 80%. And to really bring this home, we're going to add a base map. I'm going to go to the web menu, to Quick Map Services, and choose an OpenStreetMap standard base map. And that gives us a little more of the map context behind it. We have a nice effect, and we can zoom out to the rest of Denmark to see how it looks in other municipalities. And in just a few minutes, we have created a really nice, fun, historic map look, and along the way introduced you to a processing algorithm related to cartography and one use case of data-defined overrides.